Hi everybody, Lucas here with Hometown Hero. Today we have Marco Krause with Dr. Max Apothecary. Wanted to talk about a lot of different terms around hemp and what's being used and what the appropriate uses are of these words, because it's very important that everybody within the industry has the same understanding of what these words mean, the same definitions. So on that note, we're going to go ahead and get started. Marco, please give me some background context on yourself, who you are, what you're doing here, and then we can kind of dive into it.
So I am a native Bostonite. I've been here, my entire life. I went to Southwestern up in Georgetown, and then from there I ended up working in my dad's laboratory for a good while. Started in 2018.
What's your dad's lab?
Krause Analytical, and so he does all sorts of testing, but primarily has gone into expert witness testimony. And so I've phased into where I do some of the laboratory prep, but I'm not really involved in that side anymore at all. I'm just part of the family in that sense. And so from there, I ended up opening my own company. I was doing research in the lab after we started playing a little bit with cannabinoids. After 2018, we were doing just testing. 2019, I'm finishing up school, and I'm coming back, and that's when we started doing conversion research. So that's really where, 2019, the hemp industry is new here in Texas. It's new federally, essentially, as far as the definitions. And we saw CBD, which was at the time $7 a gram. That equates to $7,000 a kilo. CBN was $22 a gram, so $22,000 a kilo. We figured, hey, if we can figure out how to convert and go to CBN cheap enough, that's the way to do it. Eventually, we got stuck making all sorts of different cannabinoids because we kept getting different pathways that were yielding different results. And so from there, that's kind of how I ended up in this space. That I've just been continuing forward making products since then, I guess.
So what kind of testing do you guys do? What do you test in terms of the laboratory?
So the lab is a general analytical lab. We have all sorts of analytical capabilities. The only thing that realistically we lack, if any science nerds are out there, is an NMR, which, it's basically good for telling us the difference between one very, very isolated compound and its other form. That's really all it can do. Otherwise, we have gas chromatography, liquid chromatography, just standard ICP, IC, and just different techniques like titrimetry and sorry, I'm going to butcher this one. However you test viscosity, I think it's called viscometry technically. But we do pretty much all of it. We specialize in chromatography. But as far as what kind of testing we do testing for all sorts of sectors. We are an FDA food lab. We also do peptide testing on the new current GLP-1 peptides that are being used all over the place. We also do just potency testing in the hemp industry, and then we also serve just anybody else.
I had you guys. So there was a rumor going around that Core Powers had what is it?
Phthalates.
Phthalates. Whatever that word is. And so apparently they're toxic, and it was a rumor that this had this. And I sent this and a variety of other protein drinks to you guys because I drink a lot of them, and had you guys test them for me. And you came back and said completely normal, no elevated levels, completely healthy, everything's totally fine. I consume enough of it where it was like, if it's got something bad in it, I want to know. And you guys come back and said totally fine.
We'd be the lab to do it with. I mean, there's not many that offer, I guess, generalized analytical services anymore. It's very industry specific.
In terms of cannabis, how many cannabis tests do you think you've done for whatever you're testing for? How many do you guys think you've done in the history of the company?
As far as my company, we test every single lot that's produced every single day. So, depending on...
I mean, not just you guys, but for other people as well.
Other testing. Thousands upon thousands of samples. I wish I could give you a finite number. I know for a quarterly estimate, last year we were running somewhere around like 700 or 800 samples. Not all of them are necessarily individual sample submissions. I mean, some of them were duplicates and triplicates of certain lots that people had submitted. But it just depends on what the project is, I guess, and what they're trying to do, because there's a difference between testing potency on a extract that comes from just a batch of plants that were just grown, and then the potency of the gummies that is made with that extract. And so lots of testing. I mean, we test all the matrices, and I'd say at this point, well over 20,000 in the last 5 years.
So Marco, what's the difference between your lab and, for example, a lab the state would use if they wanted to send a product in for testing?
Krause Analytical, as far as that goes, it's a commercial analytical laboratory. We're not necessarily a state accredited lab. When I say state accredited, I mean we're not a part of DPS, if that makes sense. And so we used to be in the environmental space where we were NELAC accredited, and that's a specific state regulation on top of ISO 17025, essentially, with a superstructure, if that makes sense. What we do is quantitative analysis, depending on what it is that you need. We're not like other commercial labs. We do court defensible data rather than just number data and pushing it out. So depending on what type of lab you're going for, while they may be accredited the same, they're not doing the same thing. DPS labs, because you're talking about criminal cases, and typically you're not talking about just cannabinoids, we're talking about controlled substances like cocaine, fentanyl, things like that. It's a positive or negative test. If it's there, you're in possession, it's illegal, right? Our lab doesn't necessarily do that. We quantify it. We tell you how much is actually there rather than if it's just there. And so that's a little bit of the difference. Now, don't get me wrong, I'm sure there are DPS labs that can do quantitative analyses. It just chews up so much time and money according to their testimonies that it's not worth doing.
Section 297A, the term hemp means the plant Cannabis sativa L and any part of that plant, including the seeds thereof, and all derivatives, extracts, cannabinoids, isomers, acids, salts, and salts of isomers, whether growing or not, with a delta-9 tetrahydrocannabinol concentration of not more than 0.3% on a dry weight basis, end quote. So that is the language from the actual Farm Bill that was signed, and a lot of states like Texas have adopted that language and used that language within the state context. Within the Farm Bill, it actually says that whether growing or not. So in a sense, it's not giving an actual amount that needs to be from the plant, nor the actual method of extraction, conversion, sort of, these different things. Let's talk about that a little bit in the context of isomerization, conversion, and synthesis, and in regards to cannabis and the Farm Bill and hemp, and sort of talking
so
through all
this is really where I started. We got into the conversions kind of looking at CBD and CBN a long time ago and tried to figure out, are we within the bounds of the law? Because at the time, obviously, the CSA it's still a thing today. You can still break the law. And so when we go into that, the definition of hemp very specifically calls out a lot of different things. The whether growing or not portion is a very, very big deal because it means I can make something that wasn't technically growing so long as I don't exceed more than 0.3% delta-9 on a dry weight basis.
Correct.
That is the only definition that is truly set forth by the term hemp. It just says you can't have more than 0.3% delta-9, otherwise you fall out of the hemp regs and you're back in the CSA.
Yeah.
And so from there, it says derivative, it says isomer, salt of isomers, etc. Derivatives, when you talk about them in a chemical meaning, it means derivative of. So if I have something that, and let's say
derived from.
So if I have, let's use lemons for example. If I take lemons and I take lemon juice, I eventually can dry the lemon juice and get citric acid. Okay, that citric acid was derived from lemons. There are other ways of getting there. And there's ways of speeding up that process, obviously, vacuum ovens, things like that.
Okay, this makes sense. I like the grocery store context because look, I'm a simple person. I like, talk to me like I'm a 5-year-old, explain this stuff because it gets very, very technical very quickly.
We're using lemons and you've got that derivative. From there, I can use that citric acid, which is lemon derived. So let's use lemons as hemp, if that makes sense. I have lemon derived citric acid. I can now take that citric acid and I can make anything with it and it's been lemon derived. That end product started from a lemon, right?
Yeah.
So that is technically one of the ways you can look at that definition because it is so encompassing. But the problem is when we talk about isomerization, conversion, synthesis, or synthetic synthesis, same kind of interchangeable phrase there, isomerization falls under conversion. Synthesis also falls under conversion. So let's look at, citruses again. You've got lemons, you've got oranges, you've got, I think pineapple's a citrus, right? If I'm not mistaken.
Ruby red grapefruit.
Ruby red grapefruit for sure. They're all citruses, but they're not the same, if that makes sense.
Yeah.
And so their production's not the same either. Lemons grow on a tree, grapefruits grow on a tree, all these grow on a tree. Now, when we talk about them, they're not the same tree, if that makes sense. Meanwhile,
Correct.
When we're talking about hemp, it and marijuana are the exact same tree.
Same plant.
There is no difference.
And I think a lot of people forget this. Cannabis sativa L is what they reference in the Farm Bill, and they reference that plant for a reason because that's the only plant. And then so hemp and marijuana are government-created regulatory terms that are fairly recent in the context of human history. And so those newly created terms are essentially these two different elements, but they come from the same plant. They are the same plant. The plant is chemically almost identical.
It is identical aside from that 0.3% delta-9.
Exactly. Yeah. That one single cannabinoid is what differentiates between the two, and it's on a dry weight basis.
Yes, exactly. And that affects all sorts of things. If you want to get into the production of certain cannabinoids in the industry, yes, there are means for making it, like I was talking about with the lemons. Obviously, if we grow an entire grove of lemons and then we squeeze all the lemon juice out of there, we're not going to wait around for the sun to evaporate all that down. Okay, we're going to end up using vacuum ovens. We're going to dry it down. At that point, that could be considered synthesis because we have introduced an energy source. We have technically removed weight, and it has now been isolated. It can be called extract too. These terms are so very specific in chemistry, but when you get into what I like to call legalese, where we're talking about regulations and laws, they are all a different word, and so somebody's going to make the argument that, well, that's not the same, even though it's essentially the same. THC is THC. There's no way around that. When you talk about lemons, you have a lemon with seeds and you have a seedless lemon. They're both lemons. Now, one is technically genetically modified for different production purposes and different reasons, because I don't know about you, I don't like swallowing lemon seeds whenever I drink water with lemon juice in it. So there is reasons that these things have been made. I mean, A&M's famous for making all sorts of different, fruits that are technically modified, but they're still that base fruit. People eat them, they're not scared of it.
The ruby red grapefruit actually came from them.
Yeah, and so you go into this where you've got, and I'm gonna get more specific now, Delta 8 and Delta 9, they are both THC. While Delta 8 isn't found in serious high quantities in the plant, there are ways of taking different cannabinoids, specifically CBD or Delta 9, okay? Let's use Delta 9 because it's the simple one to understand.
Yeah.
It's the same exact chemical structure aside from one bond change.
Yeah, one molecular bond.
One molecular bond, which is technically an isomer of THC. The thing is, when you talk about isomer, it's a molecular weight. And so CBD weighs the exact same as THC. They are isomers. Now, their layout is not the same, but you can get this one to essentially rearrange as if, so say you've got 5 Legos, I've heard this one before, I'm sure y'all have heard the Lego example before. You take 5 Legos and they're stacked vertically, and then you take them and you connect them in a different way. It's still the same 5 Legos you had, so technically that would be an isomer.
Interesting.
But it's not the same as it was, if that makes sense. And so when we're talking about cannabinoids, CBD versus THC, we all know there's a big difference, right? CBD won't necessarily give you psychoactive effects. THC definitely will if you take enough. And so when we break it down, Delta 8 and Delta 9 also have their own effects. That's where I equate, a lime versus a lemon. Same exact thing, essentially, but slightly different preference based on taste.
Yeah, I remember in the beginning, most labs had trouble distinguishing Delta 8 from Delta 9. I think many still do. In terms of a test, they test very similar. In a lot of labs, still I think that's an issue. A lot of labs can't distinguish between the two of them.
So there is all sorts of different testing techniques, and obviously it's very complex how that testing is actually done whenever you go into how it's done.
And then if you're doing a test involving heat, it can change things completely as well. The actual testing process can end up skewing the results.
So because you bring that up, so let's use gas chromatography, which is also known as GC testing, okay? And so people get this terrible idea because, oh my gosh, it's getting hot, it's gonna decarb well. We go back to the regs. Some of the regs say it's on a post-decarboxylation basis. By the way, that is a reaction. It's also a conversion because you go from THCA or CBDA to CBD. There is a molecular weight change, not an isomerization. When you're talking about isomerization, you're talking about no molecular weight change. It's just a rearrangement of the actual compound itself. And so whenever you talk about these things, it's interesting because the testing can definitely affect it, because obviously you're going under heat, but depending on the regulations and what you're testing, you might actually prefer that. So let's use gummies, for example. Whenever you cook gummies, it gets really, really hot. The sugar boils at more than, 100 C. So,
yeah, it's part of the manufacturing process. You need it to flow, the viscosity, and all that
and
stuff.
so when you incorporate the cannabinoids, it's really hot in there. There is all sorts of chemistry going on. On a finite level, there is a lot of chemistry going on. So you end up getting potential conversion, you end up getting differences in what you had originally. So yeah, it's changing, but whenever you go into a gummy, it's already hot. You're assuming that you have decarboxylated, so you've removed all the acid forms and all you're left with is essentially the quote-unquote active forms of the cannabinoids. So when you go test on a GC basis, you don't care because you're not actually going to affect it all that much. You might get some conversion depending on your conditions from Delta 9 to Delta 8, but that's not necessarily the case because every lab does it differently. I mean, this is one of the issues. None of the labs have a set standard that they all have to essentially test to. When they are ISO accredited, and I'll tell you, this is just because I have the lab background, ISO accreditation means you're really good at keeping paperwork and you're really good at keeping track of where it went and how you did things. It just means you followed an SOP. It doesn't mean your SOP is correct. It means you followed it and you did it to your standard, and so therefore you're ISO.
Okay.
So certain labs, yeah, they can truly be better than others and they have the same accreditation. But the problem is when we're talking about these techniques, these are all relatively new things. I mean, up until 2019, we go back to the positive-negative test. We could tell you, hey, there's cannabinoids, or no, there's no cannabinoids. Now you're asking us to separate things that weigh the exact same. And so when you try and separate these chromatographically, it's difficult. GC testing has more what we call theoretical plates for separation. So let me explain this. Chromatography, the basis of chromatography, and the easiest definition is the separation of compounds over time. And so that's the really easy way to do it. Everybody's seen a chromatogram where you get these peaks and then another peak and then a smaller peak and then another really big peak, right? That is separating each of those compounds. And this is, when you talk about chromatography on a prep scale or an industrial scale, this is how we get some of our isolated forms. You can extract things and then chromatographically clean them up. And so this is all we're doing when we're testing. We're just verifying certain concentrations. And so as you can tell, it's already relatively complex. For a DPS lab to do that, not very easy. For a regular lab to do that, you got to have some experience and make sure that you're doing it right. And we're talking about just GC. I can tell you from experience, gas chromatography does not yield the same results as liquid chromatography, and the reason being is one is in gas phase, another one is in liquid phase. And so obviously we're talking about some serious molecular changes, and the way that they actually work is radically different. And so you can get a result over here from a liquid chromatography machine saying, hey, you've got 92% THC and 7% CBD and 1% that we couldn't really quantitate for, so it's actually a decent number. If you get 99% back, it's a decent number. Sometimes you'll see lab reports that say 102%. It's not a bad number either. They are just statistics places. That's all they are. They don't do anything else. So when you look at these numbers, it's interesting because this one says 92% on the THC. Meanwhile, this one says 85%. And it separated out more peaks than this one did. And so it's really confusing because while this one isn't necessarily wrong, this one isn't either. And so the techniques and the laboratories all do probably need to get together at some point and figure it out so that they can all be using essentially the same standards, same methods, same testing regimens.
Yeah. Marco, any products in the grocery stores that we consume on a regular basis that are manufactured using some of the processes that you're talking about?
So not necessarily using, so don't get me wrong, there are lots and lots of food products that are tested using these same essentially methods for testing. Now, as far as the production on them, I couldn't tell you depending on which one it is. My favorite reference for, I guess, the hemp industry and for a commercial process you see for extraction would be olive oil. Okay, so you talk about virgin olive oil, extra virgin olive oil, and then just olive oil. You can get olive oil from extracting olives using solvents, okay, and then you can get rid of those solvents and you have olive oil left over. You can also press the hell out of them, or like double press. I don't know exactly how the extra virgin works versus just virgin olive oil, but that's just grades of their pressing extraction and type of extraction. So they are the same techniques that we use in the hemp industry, but not necessarily for the same purposes, because when you're talking about pressing flour in the hemp industry where you're doing an extraction under pressure, you get a different yield than if you were to run it, say, through a supercritical fluid extractor. Okay, so a CO2 extractor, for example. And you'll get sometimes different products out of them. You get a higher yield out of the CO2 extractor than you do out of the pressings, because the pressings have a lot more material there in the way of getting things. Meanwhile, CO2 is under pressure, acts like a solvent, and it carries all of these things with it forward. Yeah. So different techniques, but they are used because, when you talk about olive oil, or you talk about, we do vacuum drying all the time in hemp. Vacuum drying is used for all sorts of freeze-dried foods. It's used for all sorts of food products in general. So the processes are very specific to what you're trying to make. Chromatographically, you typically see that used, chromatography, you see that used more in pharmaceutical processes and nutraceutical, like say vitamins and supplements.
So let's talk now about phytochemicals.
So phytochemicals are naturally occurring chemicals or compounds that you can find in plants or just, around the world in general. And so they don't have to be man-made in a laboratory from, two starting reactants just to get to another one, to do 15 steps of a synthesis to get to your final product.
Give me an example, like grocery store context. Like what is a phytochemical that I could buy in a grocery store?
Yeah, any of your natural fruits. You can buy them and they contain terpenes inside of them. They have naturally occurring compounds. So obviously you've got a fruit and it's got all sorts of little things like nutrients and water and stuff. But if you break all that down and go into the more specifics of what type of nutrients, what type of, say salts in said water, you end up having all these different constituents, but they are naturally occurring in that apple, right? Meanwhile, you can probably go buy them in an isolated format on just say a shelf. So essential oils, if you want to use that, for example, you can make essential oils in a laboratory. You don't have to get them from a plant. Meanwhile, getting it from a plant is probably cheaper and it's easier, and it's a great way to not have to go through a 15-step synthesis to get there.
I want to address kind of three words that have been floating around recently within context of hemp and sort of being largely misused. It's three words. It's artificial, semi-synthetic, and synthetic. And I just want to talk to you about those words and their definitions and sort of why they're being misused.
So I'm not an English major. I like to refer back to dictionaries typically when it comes to definitions. But when it comes to a chemical basis versus, once again, that legalese thing I'm talking about with laws and
what I
regulations.
Google for these words is vastly different than what I get from a Webster's versus what the actual chemical usage definition is.
Exactly. And so synthetic, when we talk about that, there is all sorts of negative connotations that people have associated with it. It's not necessarily a bad thing, but I kind of want to go full circle in this where, we're talking about phytochemicals versus synthetic chemicals.
Plant-derived versus non-plant-derived.
Plant-derived versus non-plant-derived, but at the same time, you can have something that starts from one end of the plant and ends up at the other, but you force it that way. So when I talk synthetic, I really think of things like tape and plastics and things like this, where you can start from a natural source like petroleum, and then you can go under all sorts of different syntheses to get to this final byproduct, which is plastic, right? And we use this in our daily lives all the time. Nobody has issues with it. It is a synthetic compound. I mean, most of the clothing we wear comes and uses synthetic polymers, but they're not necessarily bad things. When we talk about phytochemicals, there are phytochemicals. We've got cannabinoids, which, everybody loves them, but let's also talk about toxins. Toxins are natural. They exist in nature. And so when you talk about cherry pits or peach pits, they contain cyanide. And so that's really not good for you. As you know, I'm pretty sure everybody knows you shouldn't ingest it.
I've heard apple seeds contain something.
Contain arsenic. Yeah. And so phytochemicals don't necessarily mean good. They just mean they are naturally occurring. And so when you talk about synthetic can mean all sorts of things depending on the context it's being used in. Chemically, when we talk about a synthesis or a synthetic compound, typically we're talking about something synthetic compound that does not occur in nature. A synthesis is simply the reaction pathway. It doesn't have to be, or conversion pathway. Reaction, conversion, kind of interchangeable.
So because something was made using synthesis does not mean it's synthetic.
Yep.
Yeah, and I think that's where a lot of people get lost with this. So my understanding is, in Texas specifically, we're in Texas, we're talking about Texas. In 2011, Texas passed a law that outlawed K2 and spice. It was specifically designed to outlaw those products, and it was using the word synthetic, and those are synthetic products. So I guess how are those made?
So let me take away the K2 and spice, word. I mean, everybody knows what they are essentially. They are synthetic, quote unquote, cannabinoids, but what they actually were is this class of compounds that were studied by, I can't ever remember his first name, by Huffman. JWH series compounds, that's what they're all numbered. They're JWH-something typically, and that is his initials and then the number compound that he was researching. He synthesized these back in the 70s. I mean, he literally went into a laboratory, figured out, what chemical structure he was trying to get to, and did very, very complex organic chemistry to get to this point. Some of his synthetic compounds, quote unquote, later have been found in plants at really, really small concentrations. So some of them are no longer synthetic compounds, but they're still a part of the JWH series, which mimicked and act like cannabinoids in a way. But the problem was when they were doing the research, and everybody knows our understanding of the endocannabinoid system has changed so much in the last 20 years that research from the 80s and 90s on things that interacted with CB1 and CB2, they were very, very defined. They only interacted there. They didn't necessarily talk about what all the other effects from that interaction were. They just said they are agonists or antagonists at this spot. And so JWHs did have activity at these receptors, and so this is why they were called synthetic cannabinoids. Eventually, come to find out, we've got this entire plant with all 100 and I think one time I've heard 113. Some guy said 160. I don't believe the 160. I believe that there's...
Yeah, I've heard anywhere from 112 to 135 is sort of the range
cannabinoids,
that I typically
as far as the potential. Now,
how many of those do we actually know right now?
This is one of the problems. I mean, when we talk about plant extracts, you can extract a plant. We can go test said extract, and we can tell you with relatively good certainty what is there from what we know. But then we have all these small little peaks that pop up all the time, and we have no reference material. We have no technical standards for them that have been...
They don't even have names.
They don't even have... Well, they might have names, because obviously all these compounds have a chemical name. When you go into THC, it's tetrahydrocannabinol, but it's actually a much, much more complex chemical name whenever you actually spell it out, right? And so you're talking about it's a heptylpyran of some sort, and there's like 5 other numbers, and then this portion. They all have names. We just can't really tell you for certain that that's what it is, because nobody has gone and isolated it to the point where they've made a standard for sale to run against in a laboratory. Because when we run our chromatography, our machines, and we're separating these compounds, if we have an internal standard, or somebody has a published what's called spectra of said compound, sure, we can identify it for you, but
How many defined cannabinoids can you test for and with certainty say that's this?
So our laboratory right now does a neutrals run of 21 cannabinoids, if I'm not mistaken, and then an acids, including neutrals run of around 29.
So about 50?
No. So 29 total.
Oh, 29 total.
29 total. But that's because we haven't added more. I know other labs that do up to 50 or 60 different cannabinoids, and some of them are not naturally occurring cannabinoids. Some of them are your, let's use THCO for example. THC acetate is not naturally occurring that I know of or that I've seen any papers published, because it could be at a very, very small level. HHC turned out to be on the seeds of the plant, but not in the plant itself. Yeah. And so when we talk about THCO, it's added to the list of compounds, but it's not necessarily a naturally occurring cannabinoid, and so they can test for this.
Is it plant derived?
No. So you start with THC, which, yeah, technically I guess it is plant derived if you want to go with the chemical definition of derivative, where it started with some material from the plant, and then I ended up with this, and so yeah, it's plant derived. But really, I took THC that came from the plant, hopefully, according to definitions and laws, should have come from the plant, and then we reacted with this other stuff called acetic anhydride and go through an acetylation process to make THCO, which is a prodrug. It's not actually bad for you. I mean, when we talk about aspirin, it is acetylated willow bark extract. So you know
that.
Yeah. So if you didn't know, aspirin, it started off as willow bark extract. It's methylsilicate. One of the two. Methylsilicate is aspirin, and then silicate is I think it's the active from willow bark extract. I may be wrong on that, but basically that's how aspirin was made. He acetylated a compound from an extract and then got approval from FDA under FD&C to sell it as a over-the-counter medication.
And so I'm assuming it's no longer made from willow bark?
Probably not. It's probably fully synthesized. Meanwhile, everybody gives it to their kids because it is generally recognized as safe to a certain amount, right? Obviously, you can technically overdose on it. Same with...
You can overdose on anything.
Yeah, no, and this is the problem. And so when you look at this and you go to the testing, we can identify what we know as of now. And I'll tell you, 5 years ago when we first started in this, it was hard to get a standard for delta-8 THC that didn't have other impurities in that standard already. Yeah. And so, when we go and quantify against that, it's hard because numbers over the past 5-6 years, they have shifted somewhat because the laboratories have all had to kind of catch up with how other people are doing things, and the standards manufacturers have actually had to get better, which has in turn made the industry better, right? Because you get a little bit of the actual third-party checks where people are saying, hey, we didn't get that result, let's double check that, but it's still not to a point where we know for certainty 100% what every single compound in that plant is. And so it's a little bit difficult because when you say synthetic and non-synthetic, or plant-derived, if you want to use plant-derived, it's...
And then now we've got people making up words like artificial and semi-synthetic, which I don't know how something's semi-synthetic.
It's either synthetic or it's not.
And then artificial is a word you typically hear with sweeteners or similar products, and yet people are now trying to use that in the cannabis space, and I'm like, how this doesn't even have any context. You can't just throw in these sort of words.
And I'll be honest, I think it's a good start. It's a great idea, but it's not the right word. It's not the right way to go about explaining it, because once again, THC is THC. That lemon is a lemon, okay? Just because I have said seedless version of that lemon doesn't mean that it's bad, but it's not artificial either necessarily. It might be genetically modified at that point, but if we're talking about alcohol, for example, you get natural fermentation of different things as far as plants, fruits, berries, things like this, and it's a natural occurrence. But when we talk about the alcohol industry, what they do is they force the fermentation, they actually speed up these processes, then they distill over and make these beverages that we consume. And I'm not sure about you, I'm not going to call that synthetic alcohol, but in a way, because it's been manipulated by man, it might fall under artificial, but I think that's wrong too, because it's alcohol. Yeah. THC is THC, you can't get around that, so it's not like we're having a mimicking substitute for it. It's the exact same compound, it's just what purity, how well was it produced, where was it produced, how was it produced, I guess is a big question, but at the same time, at the end of the day, it is the exact same thing. It's not an artificial version.
In regards to K2 and Spice, obviously Texas passed a law in 2011 that made them illegal. How, from your understanding, are those products sort of in their category of being fully illegal? and obviously very harmful, and that's the reason they were made illegal, versus sort of what is now in the hemp space and what's being made, and why are they so drastically different? And I really want to understand this and also make sure everybody else understands it as well, because these are words that keep getting brought up by certain politicians that really don't like what this space is, and sort of trying to be referenced in context of those two things, which are very harmful and very bad. And so, I want everybody to have a clear understanding of like, what are those and how are they vastly different from what we do in the hemp space?
So when we talk about this class of compounds, yeah, he synthesized all sorts of compounds. I mean, I think there's literally hundreds of them, if I'm not mistaken. And some of them, if I'm not mistaken, were actually tried on humans at one point in various different studies, but they are not cannabinoids. They have similar structures, if this makes sense. And I don't want to use this as a reference, but CBN, which is one of our major cannabinoids now that is in the market, even though it's technically a minor cannabinoid, it looks a lot like a pesticide chemically, but it's not a pesticide. And so,
even nicotine is used as a pesticide. People forget that. Nicotine is largely used throughout the world as a pesticide in a lot of cases. It's a natural pesticide.
Exactly, and it's naturally occurring, as you just stated, but it, isn't necessarily good for you in mass quantities. And so you get these structures that look like cannabinoids, and sure, they interact with CB1 and CB2, but it turns out some of them are highly toxic, and some of them have all sorts of bad effects on, your physiological state as far as your mental and your just physical state with different receptor groups and different body, function groups. But it's weird because it's hard to say that they are not a bad thing, but it's also very easy to say they're listed scheduled substances. There's no reason anybody should be playing with them right now. I mean, why are we trying to push for these class of essentially synthetic compounds? Because some of them have been found to be naturally occurring, a lot of them have not. And so why are we pushing for, going back into that? Meanwhile, we have a plant that's producing these naturally occurring compounds, and we can make them, sure, in a different means than just, I guess, putting a plant between two metal plates and pressing it out. There are much different means for making said cannabinoids, but they are not these synthetic versions that he had made before. I mean, it's pretty simple. Whenever they say JWH, it's a synthetic cannabinoid, or K2 or spice, if that makes sense. It's one of the Huffman chemicals. So CB1 and CB2 happen to be receptors within your endocannabinoid system in your body. They are distributed all throughout the place, and so this is technically how we get certain interactions with the cannabinoids. But really interestingly, cannabinoids don't solely interact on CB1 and CB2. There's been all sorts of bio studies that come out showing they tie to multiple receptor groups, and each one does it differently. CBD and THC, once again, they are isomers. They weigh the exact same, chemical arrangement slightly different, but they act radically different, and it's because they are interacting at CB1 and CB2 at different rates and in different ways, and at other receptor groups within your body.
Yeah, for me, it's no different than if you go and you smoke different strains of cannabis, right? And you're going to have different effects. It's got a lot to do with the different cannabinoid structures within that strain, that specific strain, and sort of the different volumes of it. And a lot of them are vastly different, so you'll get different effects from different strains.
No, exactly. And I mean, people seem to forget that, everybody always mentions metabolism on your day-to-day basis is going to change how you feel if you're using a product that is the same thing. But part of that is CB1 and CB2, your receptors are slightly tied up, or they're interacting with things that were there already. I mean, some people don't know this. There is a compound called anandamide that your body naturally produces, which fits perfectly into those receptors, and you actually get extra production of anandamide whenever you eat chocolate. This is for both males and females. Females get a little bit more of a drastic change from it. There's an actual study showing that, but it fits into these receptor groups. So you could have metabolic processes going on that you don't realize, because it's not necessarily just cannabinoids that are interacting there.
There's a lot of different things happening in different states throughout the country right now in regards to hemp and sort of the language being used. Would it fix a lot of the issues within these states and within the legislation right now? Would it change and fix things to start using the proper chemical definitions versus what you Google and what it says for some of these words from Webster's versus what the actual true chemical definition is?
Yes. So I'll say yes. I can't tell you that it would fix things, because politics are politics. So, there is that issue still to deal with. But it would definitely be a nice start to have
some clarity,
some actual chemists involved, because when you read that 2018 definition put in the Farm Bill, it is so clearly written by a chemist that it's not even funny, because nobody else would have used all of these things unless they were just not thinking and referenced all sorts of terms that they saw in the CSA. Unless you know what these terms mean, why are you writing them down? Because once again, while the legislature here is upset that they passed a definition that allows for the production of all these things based on its actual wording, All the other states might adopt something similar if there was changes proposed by a chemist, but you're still opening up potential loopholes depending on how you word things. So yes, if you use the correct chemical terms, it's a start. I can't guarantee that you're going to get rid of bad actors. Obviously, there is always going to be bad players. There's always going to be somebody looking to skirt the regs. But as far as staying compliant and making sure that everybody is at least attempting to be on the same page, it's a start by using actual chemists whenever, doing the drafting of these bills and consulting with them. Just because, yes, lawyers, and I'll use an example, my dad said this one before, you ask a chemist a question, and you ask another chemist a question, and you ask 5 more chemists the same question, they'll all typically give you about the same answer.
Yeah, the definitions are pretty clear.
They are set. Meanwhile, you ask 7 lawyers what something means, well, they'll charge you first, and then they'll tell you a different answer from the other 6. So, it just depends, but chemists would be the way to start. I mean, if we go into alcohol...
So essentially involving chemists in this legislative process is probably the smartest thing to do and would fix a lot of this, it sounds like.
It would be a start. I mean, once again, can't fix it, it's politics, but
it would be a start.
Yeah, it would be a start.
For those of you that are completely new to this out here and sort of walking into this craziness, especially within the Texas legislative session this year and all the words being used and the press conferences and all this stuff. So, I'm a new consumer to this space. I'm hearing sort of all these horrible things being thrown out about this industry. What context would you give in sort of, oh my gosh, and what I am using synthetic, or what is this or what is that? What's your opinion on sort of the state of the hemp industry, specifically within Texas, and sort of what's being sold and where we are?
So, yes, if you're a new user and you don't understand this, I mean, obviously, one, educate yourself. This is the biggest thing you can do when it comes to any product. You need to educate yourself first, but I don't think that it is unsafe to consume hemp products. And in fact, I know it's not, because there are a lot of products that have been made in other states in recreational settings or in medical states where, they have marijuana, and there's been problems linked to these things because they have not been purified enough, they have not been cleaned up, and there are plenty of ways for getting these products and these extracts to market. But when you talk about hemp and marijuana, once again, it's the exact same thing.
Correct.
And so that lemon is that lemon. It is not going to change. THC is THC. So long as it has been cleaned up enough and is in a product that is safe for somebody to consume, yes, it is more than safe to consume a hemp product. But obviously, it goes back to check who you're buying from, check what you're buying, and just be relatively informed as far as what you're consuming.
On HHC, you mentioned that it is found on the seeds.
So there
and we've got a lot of people that will, in a variety of different contexts saying, HHC synthetic, that's not natural. That's not plant derived.
So there is, yes, it's a hydrogenated form of a cannabinoid, if that makes sense. That is why it's called HHC. It's hexahydrocannabinol. Okay, so basically you've added a hydrogen bond in here, and it theoretically becomes more bioavailable. I haven't seen any papers on this, but I have seen 1 or 2 papers that reference the fact that they were able to extract HHC from seeds. But as far as, whether that was peer-reviewed, all this stuff, I'm not going to go into it because I don't know. Okay. But yes, they claim to have found a natural source for HHC. They've found supposedly natural sources for almost all of the cannabinoids that have an alternate tail length. So you've got a 5-carbon chain on THC or CBD. Yeah. You also have this thing called the orsinol series or the veronal series, where THCV, as we all know, I guess what's it called? Diet weed is what people call it.
People are saying it can impact weight loss and kind of other stuff.
While I've never seen, once again, there are all sorts of claims out there that I've never actually seen real references for, but it could be very cool if they were. THCV only has 3 carbons on the end. THCO has 1 carbon, and so that's technical THCO. That is the orsinol series. When you say THC-O, that is THC acetate.
Got it.
HHC, yes, its production, and this is where we get into the synthetic argument. In Delta-8 and HHC, they have been found to be naturally occurring from my understanding. Delta-8 for sure. Yeah. HHC, I guess, on the seeds. Sure, while there is no real viable means for bringing them to market naturally derived from that state in mass quantity, it's obviously not worth it to the consumer and to anybody making it. There are means for making HHC out of other cannabinoids and out of other starting materials that come from hemp. Yeah. And so, same argument. Is it synthetic? The means by which you got there, sure, it was sped up. It was potentially a forced sped up reaction, which
but it's not
people
synthetic,
could say
it's plant derived.
It's a naturally occurring compound, and HHC, obviously there are different formats of it, but that HHC is still HHC, whether I got it from the seed or whether I made it in a lab.
Yeah.
And so it just depends on how you're going to define that, because, I mean, once again, 90% of the materials that people interact with on a day-to-day basis are synthetic materials.
Yeah, yeah, okay. Brother, I can't thank you enough. Absolutely incredible. A lot of this is really fascinating. I love being in this industry and learning new stuff every day. And just the information within your head is pretty incredible. Thank
Thanks.
you. Thank
Thanks
you
for
for taking the
bringing me
time to
on.
kind of teach us some stuff. And, it's been wonderful. Everybody, Marco Krause with Dr. Max Apothecary. Thank you again for being here with us. Love you to death, man. Happy hunting, everybody. Take care.